So, we are skipping 11.3, 4, and 5 for today, and we're going straight to 11.6. We're looking at shapes and if they're congruent or not. And then when we figure out whether or not they're congruent, we're going to find the missing parts in the shape. Okay? So, first, let's define congruent. We should have learned congruent already, right?
Yep.
Okay, so we're just going... So we are going to just review congruency really quick. Congruent are figures that have the exact same, not about the same, the exact same size and shape.
Hold up.
So we do have a special symbol for saying two things are congruent. It is the equal sign with the squiggle on top. Okay, I would put a box around it.
What is that thing?
Okay, what does this mean exactly?
That it's congruent.
It means it's congruent. The equal sign means they are the same size, and the squiggle line means they are the same shape. Okay, so the equal sign means same size, squiggle line means same shape. So together it means they are congruent. So, let's look at two non-mathematical examples right now. We need to decide which two are congruent. Looking at the hearts, are they the same shape?
Yes.
Yes. Are they the same size?
No.
No. So are they congruent?
Yes. No. Yes. Yes. Yes and no.
But it's size and shape. Okay, look at the lightning bolts. Even though they are not rotated the same way, are they the same size?
Yes.
Are they the same shape?
Yes.
Yes. So which two are congruent, the hearts or the lightning?
Lightning bolt.
Lightning bolt. So circle that.
That's so easy.
Okay. Now we're going to look at congruency in triangles. So we have two rules for determining if triangles are congruent. The first one has to do just with sides. So if the three sides, and then I accidentally left out part of the sentence, if three sides of one triangle, so write in of one triangle. Okay, I accidentally forgot. Sorry, guys. So just insert that in. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So, let's look at two triangles, example 2. Now, there's something a little bit different here. There are some dashes along the sides. Does anybody know what the dashes mean? Brittany? That they are the same length, right? So N and M, or the line segment NM has one dash, and the line segment KJ has one dash. The fact that both of them have one dash means that these two lines are the same length. So LM is the same length as which one? HJ. And LN is the same length as HK. So we're looking at the number of dashes it has. Okay, so let's look at it. Does it complete the rule that all three sides of one triangle are congruent to all three sides of a second?
Yes.
Yes, this side is congruent to that one. LM is congruent to HJ, and LN is congruent to HK. So all three sides are congruent. So are these two triangles congruent?
Yes.
Yes. So the answer is just yes.
Oh.
That's all you have to put. Alright guys, so really quickly, before we go on to example 3, I want to look at number 7 on our homework. Okay, looking at number 7. Sorry. Okay, looking at number 7, we are asked if CDE is congruent to JTZ. Okay, do you see any sides that are the same?
Yes. Yes.
Caleb, what sides? CD and JT are the same. Any other sides? CE and JZ. Okay. Okay, so the problem tells me that CE and JZ are the same and CD and JT are the same. So are the two congruent?
Yes. 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 No.
Wait.
No.
Yes.
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 No, they are not. Why not? Let's look. Okay, why not? Brianna, why?
Because it says is CDE congruent to JCZ, not the other way around. It has
Not quite. The order doesn't really matter, but you're correct about the marks. There are no marks on this line or this line.
Yeah.
So do I know for sure that these two are the same length?
No.
No, they do not. They just because they look the same length, that does not mean they are. No one told me they were. I cannot assume. Yeah. Why does this make a difference? Because what if I told you that the length of this side was 1.30 and the length of this side was 1.31? They look really close, right?
Yeah.
Are they exactly the same? No. So we cannot say that these two are congruent because not all three sides are given to me. Does that make sense?
Yep.
Yeah? So unless they give you all three sides, you may not assume that they are congruent no matter how close they look to each other.
Later, guys.
Okay? Now, let's look at example 3. There are two triangles in here. I'm going to do them, outline them in two different colors. Okay, so we have triangle KLM. So that is KLM. So that's this one. And we also have triangle KLN. So that is KLN, this one right here. Are these two triangles congruent?
No. Yes.
Yes. No.
Hold on.
They don't have
Hold on.
Oh, well, maybe they do.
Not right next to each other. They're the same.
That's the same
Okay.
exact triangle.
So let's look at it. KM is congruent to which line? KM and KN, right? So that's one side that are congruent. ML is congruent to LN, so that's two sides. I need my third one. Is KL congruent to KL?
Yes.
Yes, why? Because they're exactly the same. So are these two triangles congruent? Yes, they are. It does not matter. It does not matter that there are no dashes on that line because KL and KL are the exact same line. Of course they're the same size. They're the exact same line. Does that make sense?
Yes.
Okay. Alright guys, so before I give you the rule for congruent angles, I want to define something for us first. So just right underneath where it says congruent angles, will you guys draw a triangle for me?
Yeah.
It doesn't matter what it looks like, and let's call it ABC. Okay? Okay, now, hold on. What I want you to do is do one dash on AC and 2 dashes on AB. We're not going to draw a second triangle, but this is just going to help us. Okay, I have I'm looking at two lines here, line BA and line AC. The angle that both of those lines make, so the angle in between BA and AC, the one that those two lines create, is called the included angle. Okay, so label it included angle. Okay? It means that this angle is included in the two lines. So the two lines create that angle. Is the angle angle B included in AB and AC?
No. Yes. Yes.
No,
No.
because AB and AC make angle A. Does that make sense? So it's the one that's in between the two lines that the two lines make. Okay?
Okay.
Okay.
Okay. Remember how we also put a line through an angle to show that it's an angle right there, that we're measuring it? If we're looking at congruent angles, we can do the same thing that we do with the dashes. So we can do one line across to show that angle. For the other angle, we would do 2. And for the other one, we would do 3. And if we are looking at a congruent triangle with congruent angles, the angles with the same number of arches is what gives you the congruent angles. Okay? So let's do our rule for congruent angles then. So if two sides, so now we only care about 2 sides, not all 3, and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle. So the 2 triangles have these 2 sides in common, congruent, and the angle in between them is also congruent. Then the 2 triangles are congruent. Okay? Okay, so let's look at this. In example 4, I have 2 triangles here. MAX and TOY. Okay? I only know 2 of the angle measures for MAX. I only know 2 of the angle measures for TOY. Okay, it doesn't really matter what we're missing right now. Let's look at the congruent sides. What are the 2 congruent sides? MX and TY are congruent. And MA and TO are congruent. In MAX, which angle is the included angle?
60.
How did you know? Because it's the angle between the 2 lines that we're looking at, right?
They are congruent.
Okay. So which one is the included angle for TOY? Also 60. So they have 2 lines that are congruent, and the included angles are congruent. So are the 2 triangles congruent?
Yes.
Yes. Does it matter that I know that this angle is 50, but I don't know what this one is? No. Does it matter that I know that this angle is 70, but I don't know what this one is?
Yep.
No, it doesn't matter, because we are only concerned about the included angle, the one in between the 2 lines. Example 5, what if we don't know the lengths of any sides, but we know the measures of the angles? Okay? Let's check it out. So, I have angle A. It has 3 lines across it, so what angle is it congruent to? B, right? The one that has 3 lines, or 3 arches. What about L? Which one is L congruent to? V. What about D? And N are congruent. Okay, so I know all 3 angles are congruent. So are the triangles congruent?
Yes.
No.
No.
Oh.
Did I give you any rule about congruent angles?
I did say no.
These 2 are not
How?
congruent.
Wait, how?
Because it doesn't have the line.
Because we don't know the lengths of any of the lines. Just because
one
the
looks
angles
bigger.
are the same, it doesn't matter what they look like. Just because the angles are all the same, that does not mean that the lengths of the lines are all the same. So let's look at this. I'm going to draw 2 triangles, and we're going to make all of the angles the same. Okay? How about we make it easy on ourselves and do a right triangle? Okay, so first triangle, let's do kind of a small one. The 90 degrees is right here. And so let me draw that. And how about we make this one tiny? Okay, what do you guys want the second angle to be?
120.
120.
Yeah, see 120?
How about
200.
60? Okay, so if I want it to be 60, let me make it. Okay, so we know for sure that this one is 90. I know for sure that this one is 60. No, you don't have to draw it. So does anybody know what would make this one? All angles in a triangle add up to 180. So if we have 90 plus 60, that's 150. So this one has to be 30. Okay, now this one's kind of small, right? Let's make a really big one. And see if we can make a triangle that has all the same angles. So I'm even going to start the bottoms all lined up. Okay. Here's 90. So we'll draw 90. Okay, and then this one was 60, right? So let's make it 60. Oh my gosh, it's going to go off the paper. That's how much bigger it is. Okay, so it goes off the paper, but you guys get the idea, right?
Yeah.
Okay, so I know for sure that this one is 90. I don't even have to write it. I know for sure that this one is 60. And if we actually got all the way to the point here, that would be what?
30.
30. All the angles of these two triangles are congruent, right? Are the triangles congruent?
Yeah.
No. So the angles have nothing to do with the length of the sides. I can make... Well, what I mean is if we only know the angles and we don't know the length of the sides. If we know the length of some of the sides, then the angles do make a difference. But in this case, I don't know the length of any. So if I am only given angles, no sides at all, I cannot say anything about the length of the sides. Does that make sense? Okay, so that is why 5 is not congruent. We do not have enough information. So last one I want to look at, let's look at number 6. Okay, I have triangle MKNZ and triangle GWP. I have two sides that are congruent here, so this is looking promising. What are the two congruent sides? No. MK and GW. They don't give me any of anything there. How about MZ and GP and KZ and WP. Okay, so I have two sides that are congruent. Looking at MZK, what is the included angle?
30.
The 30 degrees, right? So we have to figure out what this one is, correct? Okay, I don't know what it is, so we need to figure it out. So we have 20 plus 110.
130.
Gives me what? 130. So if all triangles have to add up to 180, what does that make this? 50. So that means this one is 50 degrees. Are the interior angles congruent?
No.
No. So are these two triangles congruent?
No.
No. But, oh my gosh, these two angles are congruent. What does that mean? It doesn't mean nothing. It doesn't mean anything. Okay? Just because these two angles are congruent, we are only concerned about the included angles, the one in between the two given sides. Okay? So, hold on really quick. So, what is the definition of congruent? I need the exact, that all sides are exactly the same size and shape. So, same size, same shape. There are two ways. There are two ways for me to figure out if triangles are congruent. What's one way?
The line.
All sides are the same size, right? Like example 2, all sides are the same size. Or the angles. If I have two sides that are the same, and the included angle is the same, then they're also congruent. So there's two ways. Doesn't matter if all angles are the same size. No. If we don't know anything about the sides, we cannot make a statement about it. Okay?